titled Flight Booking System. This project is developed using Java and follow the principle of object-oriented programming. The purpose of this system is to manage airline operation in structured way. It allows user to add airlines, planes, flights and customers and to create, edit or cancel bookings. It also allows viewing detailed information about customers and flights. The main objective of this project was not to build a working system but to design it using proper software architect and OOP principles such as encapsulation, abstraction, and inheritance, polymorphism, association, and aggregation. Let's talk about project architecture. So the project architecture is mainly divided into five main packages. Here you can see model, data, commands, GUI, and main. Each package has a clear and separate responsibility. These separations ensure clean code, structure, and maintainability. The overall system flow works like this. The is here you can see GUI. User interacts with GUI or command. Command processes the request. Model handles business logic. Data layer manages storage. This separation is called separation of concerns and it improves scalability and readability. Next we will our topic is model packages. The model packages is the core of the system. It represents real-world entities in the flight booking domain. The main class in the model package are, let's see, the main class. Where is main class? Here is main class. So here you can see in model we have airline, plane, customer, flight booking system. In their airline, here you can see we have, it contains ID, name. Each flight is associated with one airline. This demonstrates association between flights and airlines. Encapsulation is applied because fields are private and accessed using getter method. Plane class. The plane class represent an aircraft. Let's see plane. The plane class represent an artifact such as it contains ID, model, capacity. The capacity attributes is important because it determines how many passengers a flight can carry. This is simple but demonstrates object modeling. Next is customer class. Here you can see customer.java and here is the code. Take a good look at it. A customer class represents the passenger who can book flight. It contains ID, name, phone, email, list of bookings, deleted flag. A customer can have multiple bookings. This demonstrates aggregation because customer contains booking objects. The deleted flag supports soft deletion, meaning we mark a customer as deleted instead of permanently removing a data. Next is flight class. The flight class is one of the most important classes. We can see it contains ID, airlines, plane, origin, destination, departure date, list of passenger. This class connects multiple objects together. It demonstrates association with airlines, association with plane, association with customer. It also includes business logic like calculating dynamic price, managing passenger list, checking capacity. Booking class. Here it is booking class. This booking class represents a reservation. It connects customers and flight. It contains booking ID, customer, flight, booking date, price. Booking demonstrates association between customer and flights. Whenever a booking is created, it is added to the customer's booking list. The customer is added to the flight passenger list. This ensures data consistency. Let's move on to the flight booking system. So this is the, here you can see, this is the central class of the system. It stores list of airlines, map of customers, map of flights, map of bookings. This class acts like an in-memory database and system controller. All major operations are handled here. Adding customer, adding flights. Here we have that code. So creating bookings, cancelling bookings, editing bookings, deleting flights, and deleting customer. This class ensures business rules are enforced. For example, when deleting a file, all related booking are also removed. Next is data package. The data package handles persistence. Its purpose is to separately store logic from business logic. Here you can see our data manager classes. This is an abstract based classes. It defines the structure for loading data, storing data. Other data managers extend this class. This demonstrates abstraction and inheritance. Custom data manager. So what is custom data manager? Handles loading and savings customer. Handle flight data storage. So flight data manager, here is flight data manager, handles flight data storage. Booking data manager, here is booking data manager, handles loading and saving customers. Flight data manager handles flight data storage. Booking data manager handles booking data storage. Plane data manager and airlines data manager, this handle planes and airlines data. Flight booking system data, this handles coordinate. This class coordinates all data manager. When the system starts, it loads all data into memory. This ensures that the model layer always works the prepared data. Command package. At last, the command package contains all user operation. Each command represents a single action. Example includes add customer, add F. Six seconds. While designing this system, one of my main goals was to ensure that the code is modular and maintainable. Instead of pulling all logics in a single class, I divided responsibilities across different layers. For example, the GUI layer does not directly create bookings. It only collects input and calls system methods. Similarly, the model class do not interact with files directly. The data layer handles files operations. This approach follows the principle of coupling and high cohesion. Low coupling means different classes depending minimally on each other. High cohesion means each class has a clear and focused responsibilities. This makes the system easier to maintain and extend in the future. Use of collection. In my system I use different Java collections such as ArrayList, HashMap. For example, flights, customer and bookings are stored using HashMap with their IDs and keys. This allows fast lookup using ID with constant time and complexity. For example, when retrieving a flight by ID, the system checks the map instead of looping through a list. This improves performance. Array list is used when order is important or when storing multiple related objects such as customer list of bookings. Data consistency. I also ensured consistency across the system. For example, when a booking is created, it is added to the booking map. It is added to the customer's booking list. The passenger is added to the flight's passenger list. When a booking is cancelled, it is removed from the customer, removed from the flight, removed from the booking map. This ensures there are no orphan objects and the system remains consistent. Error handling. The system uses custom exception classes like flight booking system exception, customer exception. Instead of using generic exceptions, customs exceptions provide meaningful error messages. For example, if a flight ID does not exist, the system knows flight not found. This improves user feedbacks and debugging. Soft deletion. In the customer class, I implemented soft deletion using a boolean flag. Instead of permanently deleting a customer record from memory, the deleted flag marks the customer is inactive. This approach is useful because it prevents historical data. It prevents accident permanent data loss. Software deletion is often used in real-world systems for audits and tracking purposes. Dynamic pricing logic. In the first class, I implemented a dynamic pricing mechanism. The price can change based on certain conditions such as booking date, flight date. This simulates real airline pricing model where prices increases closer to departure. This adds realism to the system instead of using a fixed static price. Design pattern used. The project indirectly uses some design pattern for the command pattern. Each user action is represented by a separate command class. This encapsulates request logic into separate objects. Second, a simplified MVC structure. Model representing data, view, GUI, controller, commands and system logic. This separation improves clarity. So what are the limitations? Like any system, this project has some limitation. Currently, data is stored locally. No real database integration, no Paytm system, no concurrency handling for multiple users. This could be added in future version. Thank you.